Hello everyone, welcome to Code Blog. Today we are starting with top interview 150 study plan from Leetcode, and this is the very first problem in the problem list. This is merge sorted array. So let's just jump right into the problem and see what we are being asked. So it says that you are given two integer arrays, numbers 1 and numbers 2. Both are sorted in non-decreasing order, and two integers m and n, they represent the number of elements in numbers 1 and numbers 2 respectively. So what the task is, we have to merge numbers 1 and numbers 2 into a single array, which is again sorted in non-decreasing order. And also the final sorted array should not be returned by the function, but instead be stored inside the array numbers 1 itself. So this is important. So they don't want us to create a new array which has all the elements sorted. Instead, they have given you numbers 1 array with an elongated length, which is equal to sum of the number of elements of both the arrays, which is number 1 and number 2, and they want the entire list to be merged inside number 1 itself. They don't want a new array. So let's look at it with the help of an example. Things will become much more clearer then. So here we have numbers 1, 2, 3, and notice these three zeros, 0, 0, 0, and they have given us m is equal to 3. So this m is equal to 3 means that the only elements which are considered part of numbers 1 are only these 1, 2, and 3, and these three zeros are just to accommodate the entire merged length of these two arrays. And numbers 2 has 2, 5, and 6, and they have given n is equal to 3. So basically it has three elements, and numbers 1 also has three elements, and three zeros are just for accommodating the entire length of both of these arrays combined. And the expected output, as you can very easily guess, is 1, 2, 2, 3, 5, 6. So all of these six numbers, if they are merged in a sorted manner, then this is what the output should look like. And please note that this is numbers 1 itself. So if you look at the signature, there is no return type over here. It's simply void. So what we have to do, somehow we have to update numbers 1 itself so that it has both the elements from these two arrays, and they are also present in a non-decreasing sorted manner. So let's go to the intuition for this problem. So let's start with the intuition behind this problem, and then we'll understand how to convert that into the code. So starting with the example 1 itself given by the problem. So let me just write how these two arrays would look like. So you have number 1 over here, numbers 1. It has a size of 6. Although the only elements of interest are 3, which is 1, 2, and 3, but it has a size of 6. I'm also writing the indices 0, 1, 2, 3, 4, and 5. Okay, and then I'll also write what number 2 has. So it has a size of 3, 2, 5, and 6. I'll also write the indices. Okay. Now think about this. If I were to ask you to convert this to basically transform these two arrays into a sorted array, a new array, so what you would have done, you would basically say that okay, the size of this array is m, which is 3, and the size of this array is also 3, which is n. So you would say that sorted array would have a length of m plus n, right, which is 6. So what you would do, you would create an array of length 6 simply, and then start merging these two arrays into this new array and return it. But the interesting part here is that we don't have a new array. The option of a new array is not with us. We only have to update array 1 itself. So now the interesting point to note is, if we try to start merging the elements from the beginning, then we will face certain challenges. For example, let's say, first of all, how do we find out how to merge this? This is a very classic two-pointer problem. So let's just say, forget about merging, like how to fit into this array for now. I'm just talking about how will you do the actual merging. So let's say you will put one pointer over here, you would put another pointer over here. Let's call it as I, let's call it as j. So what I can simply do is, at every step I can just compare the values of the elements at index I and index j. Whichever is smaller, I pick that one. So let's say, for example, at this point the value at I, which is 1, is smaller than the value 2. So I just simply say that I will pick 1. So this is my sorted array. I will pick 1. I will increment I. Now my I becomes over here. Oh, sorry, not over here. It will now point to second. Now I will just keep repeating the process. So now 2 and 2 both are equal, so it doesn't matter. We can increment either one. Let's just say that I increment the I index. Now I will come to, instead of over here, I will now come to 3. So now you have I at 3 and j at 2. So now you will increment j, and then j starts pointing to 5. So similarly, in this way, you will just keep comparing and incrementing until both of the indices reach the end of the array. So then it becomes 1, 2, 2, 3, 5, and 6. So this is what your sorted array would look like. So what I'm trying to do is, because since we don't have the option of storing the elements in an increasing fashion, because my array, which is also my resultant array, is numbers 1, it already has few elements in the starting of the array. But if you notice, the ending part of this array will always be zeros, and that is what we have to utilize. So what I will do, I will just flip the script. Instead of comparing from the beginning to basically get the elements in an ascending fashion, I will just flip the script and I will start comparing from the end, so that I get the largest element as my in my first iteration, that I can store at the very end of nums1, which will always be free because it has extra spaces available for us to accommodate both the arrays. So that is how I will try to fit each largest element in one iteration, and then I will try to decrement it. So let's try to see how it will look like in action. Okay, so let's just say, all right, so let's come back to this. Now we'll see how our logic is going to work. So we have again numbers 1, we have the size of 6, 1, 2, 3, 4, 5, 6. It had what were the values in numbers 1? 1, 2, 3, 0, 0, 0. So it has, basically it has 3 elements of interest, which is 1, 2, 3. This is 0, this is 0, this is also 0. I am putting the indices because these will be helpful. And then we have numbers 2, which also has 2, 5, and 6, 0, 1, 2. I will also write m is equal to 3, n is equal to 4. Okay, so far so good. Now if I ask you what will be the length of combined array, so you know that array 1 has 3 elements, which is m. Array 2 has 3 elements. Sorry, this is not 4, this is also 3. Okay, so if if two arrays have length 3 and 3 each, then my combined array length will be obviously m plus n, which is 6. So let's say you have an array of length 6, combined array. So what will be the last index of this sorted array? If the length is 6, then obviously the index will be length minus 1, which will be 5. So let's say I initialize a variable. I will call it as merge index, and for simplicity I will just call it mi. So mi will be length of my first array plus length of my second array minus 1. So this basically represents what will be the last index in the merged array, which is 5. So just to verify, you can check that this is 5, because we are going to accommodate both of these arrays inside numbers 1 itself. So I have just calculated what will be the last index where both of these combined arrays would end. So I know that the largest element among both of these combined arrays would reside at index 5. And now I also know what is the last index of numbers 1. By this I mean basically all the elements of interest that are there in numbers 1, what is the last index for that. So you know the length, which is m is equal to 3, so index would be m minus 1, 2. Similarly for numbers 2, it will be n minus 1, which will be again 2. Cool. Okay, so now let's see how this is going to work. So now you have numbers 1, which is let's just double check the values, 1 2 3, 1 2 3, and instead of zeros I'm not filling anything, I'm just keeping it empty because we will be adding the merged values over here. And this has three elements, which are 2 5 and 6. 2 5 and 6. This is 0 1 2, 0 1 2 3 4 5. So now my mi step 1, so let's just go step by step. So at step 1, mi is at 5, m is at 2, and n is also at 2. So what I will do is, your mi is somewhere over here, so this will have the largest element. So at every step, what we are going to do, we are just going to compare this with this, and by this I mean the values which are residing in these indices, and whichever is greater, I will fill that value at merged index and then decrement that particular array's index. So at this point of time, m is over here, n is over here, right? So clearly 6 is greater than 3. So what I'm going to do, I will just simply say that okay, I have found one largest element, so I will put it at merged index, which is 6, and then I will shift merge index leftwards, and I will also decrement the pointer from which I got this 6, which is from array number 2. So I will shift this leftwards. So now at step 2, what will happen, now your merged index has become, it was previously 5, now it will become 4. M did not change, it is still 2, and changed from 2 to 1. Now just repeat the process. Now you are comparing this with this. So 3 and 5. So clearly 5 is smaller. So that 5 now comes over here, which is the index 4 in numbers 1. And then you decrement this. So at the next step, merged index becomes 3. M still remains at 2. N now becomes 0. Cool. So now at step number 4, now we again compare m and n. Now m is still at 2 and n has now come to 0 index. So out of 2 and 3, 3 is greater. So now we will update mi, which is at index number 3, with 3, and we will decrement m minus minus. So now at next point, mi will point to index number 2, m becomes 1, n will remain at 0, and then now you are comparing first element, which is 2, with 0. So now both are 2, it doesn't matter. Like let's just say that we pick n. So over here, this will become, instead of 3, this will now become 2. Got it? And then just for clarity, I am rewriting where our indices are at the moment. So now my merged index will be pointing to this index. My n is still at, so n was at 0 initially, so now n becomes minus 1. Okay, and now my m was at 1, so m becomes, m was at 2 initially, then it became 1, so m is also pointing over here. So both of these indices are over here only. M is also at 1 and mi is also at 1. So now what has happened is we have basically exhausted array number 2. So because n became -1, so there are no more elements left in the second array. Now we only have elements left in the first array. So what happens is, if you go back to the problem, it says that the basically these two arrays, they are non-decreasing. So as soon as you exhaust any one of the arrays, you are guaranteed to know that rest of the array, whichever is left, is also sorted in the decreasing order. So what you just do, you just keep updating the index mi, which is the merged index, whichever array is left, and you keep decrementing both of them. So what will happen is, you will just simply update this with value m. So here obviously nothing is going to update because merged index and m both are at 2. So this will become 2, it will get overwritten, then both will decrement, both will come over here, and then 1 will get updated with 1. So essentially nothing will happen, but yeah, we still need to fill up the rest of the remaining array. Cool. And in this way, like if you now notice at the end, now numbers 1 has both of the elements, both elements from both numbers 1 and number 2 in a non-decreasing fashion. Cool. And remember, we still have to continue as long as at least one of the array is left, because for this case, what happened is number 2 got exhausted before number 1. But it is also possible that number 1 might get exhausted prior to number 2, and in that case, all of the elements which are left in number 2 have to be copied to numbers 1 to create the final result. So we have to ensure that we are repeating our algorithm until at least one of the array is left. Okay, so let's see how it will look like in code. Alright, so let's start with the code. So first of all, let's initialize a merge index. Okay, which will be length of first array plus length of second array minus 1. Now I need to decrement m because I want the index of first array. And similarly, we also decrement n because I want the last index of second array elements. Now what we will do, so as long as both of the arrays still have elements, so now what we will do, we will just compare the last indices of both the arrays. So if numbers 1 of m is greater than numbers 2 of n, so this means that the last element of array 1 is greater than the last element of array 2. So we simply copy it to the merged index will be from the first array because that is greater, and then what we do, we decrement m. Okay, otherwise the element from second array is greater, so we will copy that and decrement n, and in both the cases we will update the merge index for the next iteration. So this will continue to work as long as both arrays have some elements left. But as soon as one array gets exhausted, remember what I told initially, we have to copy the whatever array is left into the result. So we need to tackle both of those scenarios. So we can, this loop will handle the scenario when second array got exhausted first. So numbers 1, we will just simply copy all the elements from first array to itself. We will do m minus minus merge index minus minus. Now let's handle the scenario when first array got exhausted first. So in that case, we need to copy all the elements from second array to numbers 1. So numbers 1 of merge index is equal to, pick the element from numbers 2 and minus minus merge index minus minus. Cool. So now, and in the end, what do we return? That was a tricky part. We don't return anything because the return type is void. We have already updated numbers 1 with the with whatever was expected from us. So let's see if this works or not. Okay, so base test cases are passing. For case 1 it was 12300 256. We outputted 122356 and expectation is also same. So let's try to submit it and see if all the test cases pass or not. Great, so it got accepted. All test cases are passing. So I hope you liked the explanation. If you liked the video, please subscribe to the channel and hit the like button. See you in the next one.